So we made it to the next section, and we're going to teach you how to declare classes. So if you're new to this particular channel and you want to follow along with the curriculum, it is free. All you have to do is click the link in the description and you have access to it. So let's get into it. Declaring and calling a class. Creating a class. Just like the function keyword defines a new function, the keyword for defining a new class is class. By convention, class names start with capital letters to distinguish them from JavaScript functions and variable names, like this, my class versus my function. Remember that classes are blueprints. Remember this word, blueprints, for building multiple objects of the same type. The general format for declaring a class is here. Notice again, the first letter is capitalized. This is what we call Pascal casing, not upper camel case. It's called Pascal case. Some people will say upper camel case, but it's Pascal. And notice the syntax. We have the class name, we have the open and closing curly braces, and we have something here that's called a constructor, which we're about to go over. Note the keyword constructor. This is a special method for creating objects of the same type, and it assigns the key value pairs. Parameters are passed into constructor, rather the class declaration. Okay, so this is the class declaration, and you notice here the constructor is where we're passing our parameters. So remember, it is a method. How do I know it's a method? Because of the parentheses, open and closing parentheses. Now, assigning properties. Let's set up an astronaut class to help us store data about our animal crew. Each animal has a name, age, and mass, and we assign these properties in constructor as follows. So here's our constructor, here's our name, age, and mass, which is what we call the parameter. And here we're given this dot name, and we're assigning name. This dot age, we're assigning the age. This dot mass, we're assigning the mass. These are the values. Name, age, and mass are the values. Don't get it confused with the actual property, which we're actually, parameter that we're using this dot name, and we're about to help you understand what this means. The this keyword defines a key value pair. Let me repeat that. The this keyword defines a key value pair. Now this don't look like a key value pair now, does it? It looks different. So let's explain. Where the text attached to this becomes the key, and the value follows the equal sign. So you're used to the key value pair in an object having a colon, and so you have the key and the colon, which would be in quotes, would be the value will be in quotes. If it's a string, it will just be a number or in a primitive data type actually. But here we're saying that this dot key, and we're assigning it the value, like so. Constructor uses the three this statement, this dot name assigned to name, etc., to achieve the same result as the object declaration. Let object, and we assign the object like so. Now notice here that when we are creating objects, you notice that we're assigning it to the curly braces. It's a little bit different with constructor because we're actually assigning each individual key with an assignment operator. Each time the astronaut class is called, constructor builds an object with the same set of keys, but it assigns different values to the keys based on the arguments. Now here we go. Remember, parameters and arguments. It says but it assigns different values to the keys based on the argument. So although we're setting this name up, remember this is a value. We know we want it to be a name. We know age, and we know the mass. And we know we want the age to be a number, right? And we know the name is going to be a string. And mass is going to be a number as well. So we got to pay close attention here. Each class requires one constructor. Every class gets at least one constructor. Including more than one constructor results in a syntax error. If constructor is left out of a class declaration, JavaScript adds an empty constructor automatically. So if you create this class up here without a constructor, it's going to add one by default. That's not what you probably want unless you want that. But that's, again, you are the developer. You should already know what the outcome is going to be. Now, creating a new class object. To create an object from a class, we use the keyword new. The syntax is like so. So you're going to have whatever the object name is, and then we're going to assign it the new class name with the argument. So up here, this is the class name right here. We're going to have astronaut. And so astronaut is the actual class name. The argument, now understand, this is where we're passing the arguments, not the parameter, but the arguments. New creates an instance. Remember that when we talked about why objects may not be equal, it may have the exact same key value pair, but they will not be equal to each other, or strictly equal to each other, because of where they are located inside of the memory. And so here, what a new does, it creates an instance of the actual astronaut. It gives you an instance of it. It doesn't give you the actual class. It just gives you access to it. So of the class, which means that the object generated shares the same set of keys as every other object made from the class. However, the values assigned to each key may differ. Here's an example. Let's create an object for two of our crew members, Fox and Hippo. So here we have astronaut. This is what we will consider and will be our parent class. So if you watch the video where what I told you to watch about how to use a UML, it broke down how class and child, parent and child. Well, this right here, this astronaut, is considered the parent because it has all of the information in that we need to share to the children. Now here, this Fox is what we call the child, and we're passing it the information. We're giving it the actual name of the class, and we're creating a new instance of it, and we're passing the arguments. What are the arguments? These are the parameters right here: name, age, and mass. And then we want to get access with the this dot name. Now this means of the astronaut. It means of the actual object, which is this astronaut dot name, astronaut dot age, astronaut dot mass. And so when you assign it to this variable, now it now has access to this parent class astronaut, and it has access to all of this attributes. And so here, if I pass it a string, Fox, the number 7, the number 12, so that it represents the age and the mass as well as the name, and then I assign it to Fox, guess what? I'm gonna do the same thing to Hippo. So what does this mean? What a class is good for, as like we're showing you here, if to kind of put it in perspective, let's think of a employee list. You have an employee list, and in the employee has a name, an active status, whatever their role is. you put that inside of the object and you store it in the class. These are the attributes that every employee shares. So when an employee is hired on, you give it a new instance of the employee class, and all you do is fill in the information for it, and it stores it almost like in a database style. And so you'll be able to have access to it whenever you need to call it. Another example of like the zoo example, when we talked about the different animals. Well, you may have the tortoise, but you have 10 different tortoises, but they all share the same attributes, but they may be different ages. They may be of different sizes. Or you just may have what we call a cat class, but then you break the cats down into different subclasses like lions, tigers. Those are two different types of cat, or the feline. They have the feline class, which is what the lion and the tiger and the house cat shares all those attributes, but they're different because the sound may be different. I can change the sound on each one of them without having to rewrite or duplicate the same thing over and over again, which breaks the principle of dry. Don't repeat yourself. So here we do the console.log type of hippo, type of fox, and then we console log hippo and fox. And as you can see, object, object, they're both objects. And then it goes ahead and then it console.log hippo and fox, and it gives us the object with the information in it. Now, in lines 9 and 10, we call the astronaut class twice and pass in different sets of arguments, creating the fox and hippo object. The output of the line 14 shows that fox and hippo are both the same type of object. Astronaut, the two share the same keys, but they have different values assigned to those keys. Two objects created from the same class are not equal, even if the keys within the objects all have the same values. The reason behind this was discussed previously. This is where I just reminded you that the reason why both objects won't be equal is based on where they are in the memory, placed inside of the memory. And that means the location is two different locations, so they're not the same. So it's just like when you create a assembly line of cars, you may run a line of this one particular car, like the Chrysler 300, but yet each one of those cars have pretty much the same features and the same attributes, but they're different individual cars because they are separate. They're coming off the line at different times, and they're all going to different places. They're not going to the same place, but yet they have the exact same features. So after creating an astronaut object, we can access, modify, or add new key value pairs as we described in the Objects and Math chapter. Here's the example. Play around and modify and adding properties inside and outside the class declaration. Open up the in VS Code, the file. Now remember, I was telling you, create a new file. Get in the habit of creating new files and go ahead and play around with this code. It's important that you get an understanding of what's going on. We want you to see what the different outputs are going to be. Reverse engineering. Start getting into that habit of reverse engineering things so you can better understand how each one of the steps work and how it works through the process. So here, as we create the class astronaut, we only need that one class, and we create a new instance for that class, and we go ahead and we store it inside the variable. And then if we console log fox, it gives us back the information that we're looking for. And then we console log fox.age, fox.color. Then it says what here? Is it telling us that 7 undefined? Why? Because we don't have a color. Fox.age is assigned to 9. Fox.color is assigned to red. And then all of a sudden here, we have it astronaut when we called console log Fox, and it added the color red because we assigned it here. Remember that? How to assign new values in key value pairs. And then we console log age, Fox age and Fox color. Now we get 9 in red. Now, attempting to print fox.color in line 12 returns undefined. Since that property is not included in the astronaut class, line 15 adds the color property to the fox object, but this change will not affect any other objects created with the astronaut. So this class right here will not be affected if you add this particular key value pair. It just only affects this Fox. Why? Because we're only getting an instance of it. We're just getting access to all the different attributes, but it doesn't change the class. Now, setting default values. What happens if we create a new astronaut without passing in all of the required arguments? So now open up the the class, the file, or create a new file and create this. Go ahead and create everything that you need to create this file and run it. So here we create the class astronaut. We add the constructor with the parameters. Remember the terminology here. And then what do? We create a variable, declare it, and then we assign it an instance of the new class called astronaut, and we just pass into the key value pairs, which is the name and looks like the year or the age. So Speedy and 120. And so this is not actually the name, then this is going to be, yeah, it's a string. So I'm assuming that's the name of it. That's the name we're going to call the tortoise. So we console.log tortoise.name, tortoise.age, tortoise.mass. And then to avoid issues with missing arguments, we can set a default value for a parameter as follows. So go ahead and play around with this code to see what you get back, see what happens. Now, we set up a default value for the mass, which we assigned it to 54, because now we only gave a name and an age up here and we left off the mass. So now that we have the mass as default, if you leave off the mass now, you understand that it's going to give you a mass and it's going to be 54 because we set up a default. But now if you go ahead and pass in the third argument, this one right here will not be 54. It'll be whatever you pass into the tortoise variable. Now, if we call astronaut, but do not specify a mass value, the constructor automatically assigns a value of 54. If an argument is included for mass, then the default value is ignored. Try it, return to the code in the example above, and set the default values for one or more of the parameters. Okay, check your understanding. Okay, so we made it to the end of this particular section. Like I said, create a new file, go in and play around with the code, test it, figure out how to make some changes, reverse engineer it to make sure you understand how to write your pseudocode for this particular class, and also to play around with the UML. That's going to help you understand how these classes are working, and so you're making sure that you're putting the right information inside of the UML, because you want to be able to visualize it. Because as a developer, you need to visualize it, understand what it is before you write the code. So think of it like this. Give you an example. Think of it as if you're going to shoot a movie. The movies that are well written and recorded, the composition, all that stuff, they already do storyboards before they shoot the scenes. So the reason for that, so they can have a visual of what they want to do. It's the same way for us. Think of, like we said, the class is like a blueprint. Visualize it. So again, that's the end of this video. Remember, the more you do, the more you improve. See you in the next section.